Well, welcome. It's another video lecture. You haven't had one in a while. It's your favorite teacher, Mr. Greenspan, and it is a very chilly fall afternoon, and I'm here to tell you a little bit about the solar system. This is going to be the first video you're going to watch in our unit on astronomy. And this is kind of a good video to watch because that way I don't have to spend class time lecturing you on some of the names and history. And I'm also going to link this PowerPoint onto Moodle, and so you can watch it again or look through it again. But if you want to hear me talking about it first, like as if it was a lecture, please watch this video. And I'm going to kind of start here, and then I'm going to show you some things on the Moodle site as well, and show you some things that you can do to help practice or read about this too. So let me kind of start here. We're going to talk about the solar system today. You probably know that there's a sun and there are 8 planets. Pluto is no longer classified as a planet, and a planet is considered to be anything that goes around a sun. So this would be the sun here, and here's a planet going around, and here's a planet going around. And then we have things called asteroids and comets. You've probably heard of those. Asteroids tend to be chunks of rock and that are going at super fast speeds, some as fast as 20,000 miles an hour. And comets are very similar to asteroids. They are also chunks of flying stuff, but they usually have a vapor on them, a trail, a gas trail, so you see a tail on the comet as well. We'll talk more about those in some detail. And then, as you know, this whole thing is called the solar system, the moons and the planets and the sun. And then we'll get into some other stuff in a little bit. There are 5 people that you're going to need to kind of recognize their names. I'm not going to probably ask you to write them, but their names are Ptolemy, and that P is silent, by the way, Ptolemy. Copernicus, very famous. Galileo we'll talk about a lot. Kepler, and it will discuss his laws. And then you know about Newton already, but we'll kind of re-mention him because he was influential here as well. So those are some of the names that we're going to talk about. Remember throughout the video that you can always pause me talking and just stop, or you can go back, and if you want to hear something again, just go back. So we're going to talk right now about 300 years of history, and Galileo is the one who really started doing major observations with a telescope. He did not invent the telescope, but he was one of the guys who was responsible for really using it for astronomical reasons. And you notice he came after Copernicus, and we're going to start with Copernicus, but he's around, late 1400s or so. So I want you to kind of keep in a mind frame that he didn't use the telescope, and he didn't have very high-tech equipment or anything like that. None of these guys really did, but Copernicus in particular. And so who was he? His name is Nicholas Copernicus, and he came up with the idea that, number one, the Earth moves, and it moves 2 ways. As you probably know, it rotates, and that's called a period, and for us, it's every time it rotates once around, it's a day. And then it also moves its whole body, the Earth's body, around the sun, and that's called a revolution, or revolving, and that is called 1 year. So how long it takes the Earth to go all the way, or a planet to go all the way around the sun. He also determined, and I'll show you this in another slide, that the Earth's actually got a tilt of about 23.5 degrees, and that it travels in this somewhat circular pathway. And this is actually not the greatest picture, because this is the old way of doing it that he came up with, called the heliocentric model, which says actually that the sun is at the center of the solar system and we go around it. Now, that was not thought of before that in religious purposes. People thought that we were the center of the universe and that everything went around us. Copernicus came up with this model that said that may not be true. And so here's Earth, as you can see, on the same tilt the entire time. If you look at this line right here, the Earth has always got that same tilt. And we'll talk about the seasons in a little bit. This is called heliocentric. Centric means in the center, helio means to go around. And of course, as I mentioned, with the tilt of the Earth, when you get to something where the sun's here and the Earth is here, you can see that if in the northern hemisphere we're much closer to the sun, or get more direct sunlight. I shouldn't say we're closer to the sun, but we get more direct sunlight. Whereas over here, when the sun comes and hits Chicago, roughly about right here, we're tilted away from the sun and we're not getting as much direct sunlight. I'm going to show you this in other presentations, but I want you to definitely know for right now, we're going to do an activity with this, but I want you to definitely know for right now that we do not have winter because we are closer or farther from the sun. This picture is technically not correct because it shows the Earth being much closer here than here. In reality, it's nearly a perfect circle. Nearly. We call it an ellipse. And so, as this shows here, if this was the northern hemisphere and the Earth's on a tilt, and that blue line is the tilt, this is going to be like the northern hemisphere, North America, and you can see that the sun goes directly and hits it. Whereas these guys down here in South America, in July, they're kind of not really tilted towards the light. You can see it's almost like they're turned away from the light there. The light's going to be coming this way, and they're down here. So that's going to be their winter. And this is called the Copernican model. The other second person to come around was Galileo Galilei. Galileo, again, I won't read this entire slide. We're going to do tons of activities. But Galileo did not invent a telescope. He used it, though, and he came up with all sorts of discoveries, such as the fact that the moon has craters and mountains on it. He's the one who discovered that we have moons that go around planets, like Jupiter and like Earth. He looked at Venus and talked about what made it special. We'll talk about that. And then he started to even come up with the idea that our solar system is just one of many solar systems that's called the Milky Way galaxy. A galaxy is a bunch of solar systems put together. And then the last thing he discovered was that there are sunspots that are on the sun, these dark colored circles or spots on the sun. And we're going to do activities with all of these. Look at the upper left-hand picture right here. You're going to see his drawing of the moon based on his telescope use, and then that's the actual picture of a photo of the moon. And his quote right there at the bottom just is he was very frustrated that a lot of people didn't want to use the telescope and really think of using it. And the reason for that is that he had some implications, much like Copernicus, that Earth is not only is the Earth not the center, but things travel around the sun. The sun is really the center of the universe, and the Earth is just another planet. And a lot of people didn't like that. They didn't like the idea that he was saying that the universe is huge. It's made up of lots of galaxies and lots of solar systems. And that idea was going to be very dangerous because there was a religious problem. Back in the days here, religion, Christianity especially, kind of said that God created the heavens and the earth. And therefore, people did not want to believe that the Earth was just another planet that went around the sun and that it wasn't the center of the solar system. So it was very, very controversial. And at one point, Galileo was actually even sentenced to prison for coming up with these ideas. So he was very frustrated. No one would just kind of look at his telescope and look at what he was seeing. And of course, we've changed since then, and a lot of people believe in the idea of how the solar system got started. We'll talk more about this later too, but there's a belief that the Earth is very old and that there's all these kind of processes like volcanoes and earthquakes that happen, and there's ice ages and there's evolution. All of these ideas that we're going to get into this year. Well, we won't get into evolution until you get to biology, but the rest of these, we're going to talk about these a little bit. And of course, that's a really strict problem with the Genesis book in the Bible that says that God created the heavens and earth, and we're not just another planet. We are something special. But science kind of had gone and said, okay, that may be true. And so science kind of says, here's what we know is happening, but we don't really know how it was created. And sometimes that makes religious people feel a little bit better because there's still the room to understand that there might be like a God that created something at some point. But scientifically, there's no evidence for religious type events. Religious events are not really scientific. They can't be tested. So the stuff that we're talking about here is stuff that's been tested and recorded. And everybody, of course, has to decide for themselves what they're going to believe. And the next guy came up with two laws that I want to tell you about, Kepler. And Johannes Kepler believed in two things. He believed that each planet moved in an elliptical orbit, and that they were one after the other. So that Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, that each one kind of was one further circle higher around the sun. So each planet moves in an orbit, and each planet has a spaced out, what we call a vector, or an area that it goes around for to go around the sun. I'll tell you about that word, but it's not as important right this second. But let me show you. I don't know what that was. Let me show you this. This was his data. His data was that he was very good and used really a lot of his own just naked eye, and he started marking kind of like how Earth was rotating, and he noticed that Mars, for example, was always lagging behind. So here's Earth, there's Mars. Here's Earth, Mars is still back here. Here's Earth, there's Mars there. And so he realized that Mars and the rest of the planets must be farther out from the sun, and so it's got a larger circle to have to go around. So it's always kind of lagging behind Earth. And in truth, that's how it works. And of course, Jupiter would be way, way, way lagging back here because it's got a larger orbit. And so he took this data, and it was very complete data. So if you take a look at the lines here, these are the lines that correspond with the Earth planet. Let me go back one more, just so you can kind of see that fully. So he was lining them up. So of course, here's Earth, and that's the corresponding Mars. And he said the only way that this could happen is if Mars was actually out further, one planet further than Earth was. And you already know about Isaac Newton. You already know about his 3 laws that we've gone over, but he again came up with this idea of gravity, that there's this force acting, and he wondered if stuff like the moon was going around the Earth because of gravity too. Furthermore, he questioned whether the Earth was going around the sun because of gravity too, and that's what keeps it in orbit. And in fact, all of those are true. And by the way, the apple never fell on his head. I know that's a rumor. And so that's the end of this slideshow. I know I went through it quickly, and I'm going to have it up on Moodle for you. In fact, I thought I'll show you here. I've got some things started about how planets move and some different links on here. I'm going to keep building this, but this is your Moodle page in ILS. And you can see I've even introduced to you some of the terms here. And when you click on that solar system, you'll get the PowerPoint. Or I've also made it so the PowerPoint's right down here on the solar system. And then we'll see how you do. I really appreciate you guys watching these. Thanks a lot. Bye.